Good day everyone, my name is Anthony Nathaniel, and in this video we have finally come to the place of calculation on our statistics and on the previous episode, which was on finally on mensuration, that is the volume and area of solid shapes, right? Now before I start this video, I want to give a little bit of tip to you guys. Now in this video there's another channel of this education zone. This is global education zone channel, and there's another channel under this global education zone. It's known as the Gleb Zone Study Tips channel. Now I noticed that I'm trying to teach you guys on YouTube, right? But at times it can seem difficult to grasp the things I teach and other things. So now in this other channel, I post videos. I will be posting videos too on how to study effectively through YouTube. So that's how to get educated on YouTube. And hopefully in coming days I'll release videos to teach you guys how to understand and how to gain the most from consuming your data on YouTube. So whenever you go on this channel, how do you gain the most from it, and how do you apply your time and your data effectively? So I want you to watch out for that. I will still be giving more information on that later on, but let's delve into today's work. Now today I'll be giving two examples on the previous episodes. So we've gone back there, and this first example will be based on the episode on statistics. So on this example, now we'll be looking for the class interval, we'll be looking for the class the class midpoint, and then we'll be looking for the class boundaries. So look for the class intervals, midpoint, and boundaries. So first of all, at times you might be asked to fill the tally. So the tally is basically a representation of the frequency in with the use of strokes. So if we have this 11 now, I want to represent it in the tally. So we just say 1, 2, 3, 4, and then stroke 5. 1, 2, 3, 4, stroke 5, and then add 1. That will be 5 plus 5 plus 1. That's 11. So that's an example of tally. So I assume you've understood that, but this is just a demonstration in case you've not seen it before. Now let's go straight to the first part of the question. So we are asked to look for the class interval. So and then after that we'll look for the class interval with the highest frequency. So the first part of the question. So what is the class interval with the highest frequency? Now these are the class intervals. These intervals contain the lowest class interval and the upper class interval. And this first figure is known as the lower class limit. This bigger figure is known as the upper class limit. So moving on, we have the frequency is 11, right? So this one is 16, this one is 9, and this one is 4. So we'll just look for the one that has the highest frequency, and that will be the mode of the data. That's the modal class. So for this group of data, we can see that 16 is the greatest, right? So 16. So that 16 can be traced to the class interval of 62 to 66. So that means class 62 to 66 has the highest frequency. So then moving on, what is the class interval? Sorry, what is the class midpoint? So in the previous video I gave the formula as the upper limit plus the lower limit divided by 2. So let's look for the class midpoint of the modal class. That is the class with the highest frequency, which is class 62 to 66. So what is the midpoint? So the formula for that is, what is the lower boundary? Last lower boundary is 62, and then the upper boundary is 66. So 62 plus 66, we add them together and divide by 2. In other words, we are looking for the average of the class limits. The 62 plus 66, that will give us 128. 1 divided by 2, we have 64. So that means the midpoint of the modal class is 64. So lastly, the last part of this question, we are looking for what is the class boundary of the modal class. So you can see we are focusing on the modal class, but these calculations can also be extended to every other class. This first class, the second, the third, and the last. So you can add, you can even form new columns on this table, or you can do one at your convenience. So, but you can still apply this in every part of this table. Now the last part of the question, what's the boundary? So the boundary is basically when you subtract 0.5 from the lower limit, you get the lower boundary. When you add 0.5 to the upper limit, you get the upper boundary. So for this is 62 to 66. The lower limit is 62. We subtract 0.5 from 62. So that's 62 minus 0.5. That would be lower boundary. Let's denote it as L. Then for the upper boundary, we'll take the upper limit and add 0.5. That would be 66 plus 0.5. That would be H. Sorry, that would be B. Let's call it B. So that means the lower boundary will be 62 minus 0.5. That's 61.5. Then the upper boundary will be 65.5. So the lower boundary is 61.5 and the upper boundary is 65.5. So that's how to look for the boundaries of data like this. So let's move on to the next part of this question, of this video, where I'll be talking about mensuration. So in that part of the mensuration, we'll be dealing with composites. So because that will cover almost every aspect of mensuration. So let's go to the next part of this. So let's talk about composites. So now we have a composite. This is a composite. In the earlier video, I talked about a hut. So let's draw a hut, a typical hut. This is a typical hut. This is how it looks. Spatially, it looks like this. So this is kind of like a traditional building, but we are not concerned with the aesthetics or whatever. We are concerned with the geometry and how to calculate the geometrical properties like the volume. So we're looking for the volume of this figure. Now the question says, this is a composite solid consisting of a cone on top of a cylinder. Just as I said, the height of the cone is 20 centimeters. So from the top to the bottom here is 20 centimeters. And then lastly, they said the height and the base diameter of the cylinder are 40 centimeters and 30 centimeters respectively. So the height of the cylinder will be 40 here. That's 40. I just put it in dimension lines. So and then we have the base diameter will be 30. So the diameter from here to here, which is from this side to this side, will be 30 cm. So I'll ask to look for calculate to three significant figures the volume of the solid. So when we're looking for the volume of a solid of this nature, we'll add the volume of each of the parts of the solid. So we have this solid is a composite that is made up of a cone and a cylinder. So we're going to add the volume of the cone to the volume of the cylinder. So let's do that. So this is a cylinder, right? You can as well separate them so that it will be easier for you to understand how it is. Let's take them apart. Assuming we take the cone of the cylinder, or rather, assuming we remove the roof from this house, the roof will be one place and the other part will be another place. So for this cone, we have this side is 40, the height of 40, and so when the diameter is 30, the radius is half the diameter. That will be 15. 15, yeah. Then for this cone, we also have 15 as a radius because it has a uniform cross section. That's 15. Then the height of the cone is 20 from the top to the bottom. That's a perpendicular distance. Now the volume will be the volume of the cylinder plus the volume of the cone, right? So that will be, what's the volume of the cylinder? Let's call it that will be pi r square h. That's pi times r is 15. That's 15 square times what's the height? The height is 40. Then plus the volume of the cylinder, which is 1 over 3 pi r square. That's 1 over 3 pi times r square. That's 15 square times the height. Yes, that's 20. So when you evaluate everything, you are going to get the volume of the cone as 1500 pi, and the volume of the cylinder will be 9000 pi. So when you add everything together, 1500 pi plus 9000 pi, that would give us 10,500 pi, and the unit is centimeter cube because the unit of volume is cube. So that will be volume of composite. That's 10,500 pi centimeter cube. So that is it. And but now they said to three significant figures. So that is already in three significant figures though. 1,500, 10,500. So if it is not in three significant figures, you can approximate the fourth to the third. That will give you three significant figures. So that is the calculation on both mensuration and statistics. Thank you for watching.